All right, here we go. Let's start out with, let's go 7 first. All right, let's start out with 7, everybody. I know it's pretty tempting, but are you allowed to cross off the 2 5Ys? No, why not? There's addition in the bottom. I know it's so tempting, but don't do it. You see addition or subtraction in there and you're asked to simplify, look to factor first. So there's nothing I'm going to do with the numerator of 5y, but what can I do with that denominator of 5y plus 5x? What can I do with that denominator? 13, what can I do with that denominator? Yeah, be simple, right? Take out a GCF of a 5 and what's left? Good. Could I cross out the y's now? No. What's still with it? Addition. Don't touch them. But I can cross out at least one thing up here. Not the y's, though. But the 11? No 11 today? Oh, that's fine. You weren't here on Friday. Here you go. I can cross out the what? 28? That's right. I forgot. We got 30 kids and no 28. 17? I can cross out the 5s. Because, ready? What's happening between the 5 and the y? Multiplication. What's happening between the 5 and the darn parenthesis? You can cross out if there's multiplication, but not addition and subtraction. So the only thing I have left is y over y plus x. And I know, guys, it's tempting. Don't try it. Don't be a hero. All right, these guys stick together. All right. We're good there. What else did I want to try out here? You're going to go on your own. Does anything look intimidating here? I don't think there's anything. I at least want to go try one more here. Number. No, I'm not going to factor because A is different than 1. No, I'm not going to fall into that trap. All right, you guys are more than capable of factoring something. Which one? 12? All right, we can do 12. Let's try it out. And then we'll go to some Regents problems. Okay, 12. Anybody want to cross off the x squareds? Yeah, good idea. Okay, you can't. We're done with that. Hopefully, we're done with this. There's subtraction in there, so try to factor. Somebody factor the top for me. 26, help me factor the top. X squared minus 25. Do we have a 26 in the house? X plus 5. This is difference of 2 perfect squares. Good. At the bottom, x squared minus 2x minus 15. That factors into, think about 2 numbers there. 17 when you're ready. Think about those 2 numbers. $17? Okay, plus 3 minus 5. I got it. Multiplies the negative 15, adds the negative 2. Now you're ready to simplify. What can I simplify? 17. Good. All right, what's left? What's left over now? 8, what's left over? Yep. Anybody want to get rid of the x's? Anybody want to get rid of the x's? Me neither. Okay? Yep. All right. I think you guys will be good to go for the remainder of that homework. Okay? Everyone good? Put that away. Let's get the Regents out. We're going to start on question 4 together. I've selected some random ones here. All right, I know this may be painful and it may not be your fault. So, all right, I'm not going to blame you if you don't remember this. I'm not going to be like, I can't believe you can't remember this. All right, you may have not even learned it. Who knows? All right, that's what I'm here for. All right, which table represents a function? All right, which table represents a function? I'll leave it. I'll throw it out to you guys if you want to drop some knowledge on me and your classmates. Anybody remember the rule that it's got to follow if it's a function, Tom? X values cannot repeat. Okay, so let's put some notes down here too. So when we go back and look at these, all right, a function means no X value repeated. Okay, no X value repeated. So you look at these tables right now. 3 out of the 4, you have X values that repeat. Hey, X values, not F of X. I don't care about F of X. I care about X values. All right, I want to make sure no X values are repeated here. All right, I don't care about F of X at all. So out of these 4 tables, which one do you have no X values repeating itself? What do you got for me? 18, which table satisfies that? Number 3. Everyone see, I got 2 and 2, 4 and 4, 0, 0. I got 0, 0 again. All right, I have X values repeating. Everybody good? Function, no X values repeat. There's other things associated with a function, but I'll get to them when we come across them. Next one we got is 9. 9. What's the domain of this graph? X plus 4, the square root of X plus 4, domain. Well, first of all, domain, what values are my domain? X or Y values, domain. X values, all right? So domain, I'm looking at my X values, the X axis. Where does this graph start on the x-axis? I don't care about the y. Where does it start? 17, where does it start on the x-axis? At -4. All right, so 1 and 2 are out. Now the difference here, it's getting greater, right? All the x values, it's getting greater. Now, should I do no or equal to or an or equal to? Why? Because there's a solid, I don't like to say point. Yeah, solid point here. If I did not or equal to, what would I have here? An open circle. Okay, open circle means does not include, closed means it does include. So we're going to choose everything greater than or equal to -4. Don't go anywhere. Bonus time. What about the range of that graph? What about the range? Now what values are we looking at? All our y values. Anybody describe what you know about all the y values now? Go ahead, Matty Ice. Well, I know you see a point here, but isn't there, like, here you go, here's a y value, right? And that's on the graph. So I can't just say 2, because there's... Oh, okay, sorry. So yes, it would be anything greater than or equal to 0, yes. Anything above my x-axis. So from here on, correct. Anything bigger than 0. Good. Questions from you guys here? All right, let's keep this train rolling. I got a bunch today, I think. 15. All right, I got 2 graphs. At which value is f of x less than g of x? Again, f of x and g of x are just another name for what values? So I want to know at what point here do the y values are less than the y values in g of x? All right, a couple different ways you go about it. It is multiple choice, so you could literally plug each in and find out when f of x is less than g of x, or you could go to your calculator, which I'm going to have you guys do right now. Go to your calculators right now. Go to your y equals screen, type in both equations into y1 and y2. Go to your table, and we'll figure this out when the y values for f of x are less than g of x. So I got 3 to the x. And then I have 2x plus 5. Okay, go to your table. Why are mine going by 2s? Okay, everyone ready? How to look at the table. We're comparing the y values. Here's f of x in your first y column. Here's g of x. So let's go with our first choice. Let's see, what's our negative at -3? Is f of x y value smaller than g of x? It is? That's positive, guys. That's negative. Help me out here. Stop me if you don't know what's going on here. Are we okay? I got both graphed. I have both graphed. Here's f of x y value. Here's the g of x. Is this smaller? No, the 0.03 is not smaller than -1. So it doesn't work for -3. What about -1? I'm just going through the choices. At -1, f of x smaller than g of x. Do we got it? So which one do we have here? -1. Questions? And again, write it down for me here, because I just don't want you to circle one and that's it. All right? Use graphing calculator. Look at table. Questions, comments? All right, let's keep it going. 25. Let's get out of the multiple choice section now. Okay, graph y equals anybody remember these symbols here? What they were called? Absolute value. Okay, absolute value function. All right. Do you know where it is on your calculator so we can graph them? Do we remember? All right, that's what I'm here for. Here we go. Go to your y equals, clear everything out. Okay, how to get the absolute value symbol? One of two ways. You can go alpha window. Okay, you can alpha window, and it should be choice 1, absolute value. You guys that maybe can't get alpha window, everyone ready? Go under math button right here on the left side of your calculator, the math button. You can hit the math button, scroll over to NUM. Scroll over to NUM, and it's the first choice. All right, so either alpha window or math, scroll over to NUM, absolute value. All right. So you can put that right in right now, absolute value, x minus 3. Okay, take a look at your table and start plotting some points, positive and negative right now. Positive and negative. Please provide, anytime you graph, please provide a table of what you're graphing as well. So just like we did for the parabolas, you guys on the left or right-hand side of that graph should be doing an XY table for me. All right, either on the left or the right-hand side, doing an XY table of the points you are graphing. And again, we want to get some negative and positive points in here. -1 is over here, or -1. Okay, what about your positive points, though? We got 1, 3, right? Mm-hmm. It's just when you went past here, check 4. What's 4? 4, 1, right? So 4, up 1. What screen? Like it doesn't show like yours. It's like 0, 3, 1, 2. What do you mean? Okay, it's because somebody's been missing. Yeah, because your table's going by 3s. That's what that means. And then start out. Okay, now you can scroll up and down for different tables. Go ahead, graph it in. Looks like an absolute value. Value starts with V, and that's what these graphs look like. I'll wait till everyone gets it graphed. Does this graph stop at a certain point? Nope. So what am I trying to tell you to have at the end of your graph on each side? Arrows. Yes, these graphs keep going on. Okay, where's the other side here? Where's this graph here? Because it should look like that up there. So I need, because it should look like this, so I need to see where I'm missing the other side here. All right, I need that other side. Good. Okay, looks like we're good to go. And then there's a secondary question which says, explain how this graph has changed from y equals regular absolute value of x. So if you need to, again, if you need to, you can go back and graph both of them now. So x minus 3, then do absolute value of x to see what that looks like, and then look at the two graphs. There's the one you graphed. There's x. What happened to x minus 3? It moved 3 in which direction? Here's x, absolute value of x. Here's the one you graphed, x minus 3. What happened? How are we getting left? How did it? Oh, that's the original. The original one's right here in red. Oh, that's the original. It moves to the right 3. And hey, shouldn't we? Hey, I shouldn't even have to graph. We spent a lot of time and a lot of work on this last unit. When there's a -3 inside, what happens? Right 3. Okay, if it was on the outside, what would happen? Come on, if it was on the outside, if I had -3 on the outside, it would move down 3. The rules still are the same, even though this isn't a parabola. Okay, so moves the graph right 3. Questions? Maybe 1, 2 more maybe here. No, we definitely got 2 more. 28. The difference of those two multiplied by 1/2 x squared, what's the result written in standard form? I know you're able to do this because you did it with me. All right. First, we got to find the difference between these here. So let's focus on this. Does anybody remember the rule? This is the very first thing I did with you guys when you subtract. There's something I have to do before I start combining like terms, specifically when you subtract. Yes, Emma?
You change all the values in the second one opposite.
You change the signs in the second polynomial. So here we go. I'm going to keep 3x squared minus 2x plus 5 all the same in the first polynomial. When you subtract, you need to change the signs in the second one. So what's this positive x squared going to get changed into? Minus x squared. 3x will get changed into minus 3x, and then plus 2. Now on your own, go ahead and combine all your like terms. And I'll ask somebody here in about 30 seconds what you end up getting. So combine all your like terms right now. Let's go. Okay, when you combine your like terms, what is that equal to? Go ahead. Let's get away from that. 19. Okay, how'd you get 4x squared? 2x squared, keep going. Okay, that's the difference. Take this now and multiply it by 1/2 x squared. So I'm going to need 3 people right now to help me distribute this. Who's got 10? 10? Okay, Matt, ready? 1/2 x squared times 2x x squared. Ready? 1/2 times 2. 1 x squared times x squared. What do I do? X squared times, you're multiplying. X to the 4th, you add the exponents. So I have 1x to the 4th. Are we okay on how we got there? 1/2 times 2 gives me the 1. X squared times x squared, x to the 4th, add your exponents. All right, next up. Here we go. Matt, again, let's go. Redeem yourself. Ready? 1/2 times -5. -2.5 x to the cubed. And finally, distribute those last two together. 22. 1/2 times 7. Plus 3.5 x to the squared. There's nothing to combine because the 7 didn't have one. So that is where we are. Questions? Hopefully you're starting to realize, oh boy, we need 2 months. Darn right we do. Last one of the day here, 27, going backwards. I'll let you read it through and we'll talk. All right, Johnny and Sarah saving money for a car. It's cute. John's going to save using this equation. Sarah's going to use the g of x one. And I want to know how many weeks are going to be the same amount. How many weeks are they going to save the same amount? suggestions on what I should do then with these two functions if I want to know when they're going to save the same amount. Hannah? All right, let's roll. Let's set them equal. I want to know when they're going to be equal, so I might as well set them equal. And I'm going to try to solve for x. This should be pretty recent here for us. That's why I picked it. This should be pretty recent to solve for x. Okay, don't forget everything we've worked so hard for here. All right, what do you want to try to do to start up here? 3. What do you want to try to do to get this started? Get one side equal to 0. Because you see an x squared, you know you're probably going to have to do some kind of factoring. So get one side equal to 0. So x squared, let's write it in standard form. What should come next if I write it in standard form? 4 minus 5x, keep minus 14. Nice job. And I think we got to go back to that last problem because I don't think I finished it correctly. So we'll do that in a second. Factor, complete the square, quadratic formula. Those are your 3 options up here. All right, factor, complete the square, quadratic formula. Because of the way this is, I think everyone in here should be able to factor that. Find your 2 numbers. -27, your 2 numbers, 14 and 5. -2. Do -2 and 7? We sure? What's 7 and -2? That's +5, right? Right? So do what with the signs? There you go. Switch the signs. Draw your line down. Set them equal to 0. And let's solve these beasts. 2 answers you get out. 8, 2 answers you get out. All right, let's have an awkward staring match with each other until somebody tells me why I'm not done with this problem. I don't have to do y. It just said solve for x. After how many weeks x? Let's have this awkward staring match. Callie? Why? Can't have a negative amount of weeks, right? That's silly. So yes, -2 is gone. So it's going to be 7 weeks. Go back to that last problem because I didn't answer the question correctly. I'm going to get a point off myself for this. Anybody want to stare awkwardly at each other again before they tell me what we needed to do where I'm going to get a point off? Actually, no, we're good, aren't we? Standing. Okay, never mind. Never mind. All right, calm down, everyone. Second guessing myself. 4, 3, 2. What? I didn't think it was. No, I didn't think it was in standard form. That's what I didn't think it was. But 4, 3, 2, we're good. Okay, answers are up on Aspen for tonight's simplifying. Make sure you take a look at them.